Good afternoon, sixth graders. This is Mrs. Dubé coming to you with lesson 13.4 on measures of variability. And luckily, this lesson is just a review of 13.2 and 13.3. So let's get into this measures of variability. Essential question, how can you summarize a data set by using range, interquartile range, and mean absolute deviation? So we know range is highest minus lowest. We know the mean absolute deviation from yesterday's lesson. The only new phrase or term today is interquartile range. So connect. A measure of variability is a single value used to describe how spread out a set of data values are. The mean absolute deviation, or MAD, is a measure of variability. Variable is the base word of variability, and variable means things differ. Okay, so in gym class, the students recorded how far they could jump. The data set below gives the distances in inches that Manuel jumped. What is the mean absolute deviation of the data set? Okay, so it has it all written out for you right here. Find the mean absolute deviation. So we know how to find the mean of a set of data. We know we add them up and divide by how many there are. The other thing I want you to take a look at is the table over here. And I'm just curious, why is 57 in every row? So think to yourself right now while I'm circling these, why is 57 in every row if you think back to Mr. Damiani's lesson yesterday? Your answer should be is because 57 is the mean, right? So the table is showing the difference between 57 and every data point. Okay, so here are the data points, 54, which is right here, 58. Of course, we do 58 minus 57, so we don't get a negative number. These are really just the absolute values of the numbers anyway, but I think they just put the higher number on the left because that's what we're used to. But we know absolute value, it wouldn't matter because the signs are dropped with absolute value. So if we were to add the data values and divide the sum, we would right here be writing 58, 56, I'm just getting these from the chart above, 59, 60, and 55. And there are 1, 2, 3, 4, 5, 6 pieces of data. So put the 6 underneath. When we add these up, we get 342. We divide it by 6 and we get a mean of 57. But we already knew that, didn't we? Because in our graph right here, the 57s are already written. So we know if 57 is in every single one, then that must be the mean. And then we're subtracting each piece of data. So when we subtract 57 minus 54, we get a 3. This would be a 1, 1, 2, 3, 2. So the total distances from the mean is 12, and then 12 divided by 6 is 2. So the mean absolute deviation of the data is 2 inches. And again, this is just a review from Mr. Damiani's lesson yesterday. So if you need to pause and rewind it, go back, take a look again, feel free. If not, let's move on. Okay, so we'll move on to the next page. Range is the difference between the greatest value and the least value in a set of data. Interquartile range, and I think this is new, but we have seen them on the spirals, number 20 on the spirals. Interquartile range is the difference between the upper quartile, which I did with you for 13.2, and the lower quartile of a data set. If you remember when we did our dot plot, we had the lowest number, we had 5 dots we had to plot. The highest number, the median, then it was like the median of the lower set called the lower quartile, the median of the higher set, and then if you remember, we drew a box like that, and our whiskers came out like that. So the interquartile range is now the difference between the upper and the lower quartile. So we would take this and find the difference. So you already know how to make that whole box plot with the upper and the lower quartiles. So now all you have to do is subtract the upper and the lower. So range and interquartile range are also measures of variability, which we're talking about in this lesson. So if we scroll down, here's an example. Use the range and interquartile range to compare the data sets. So the box plots show the price in dollars of the handheld game players at 2 different electronic stores. Find the range and interquartile range for each data set. Then compare the variability of the prices of the handheld game players at the two stores. All right, so they've already done the box plots for us, store A and store B. So if we look at store A and store B, we would calculate the range. Okay, so we have the costs of handheld game players in dollars. So that's the title. So we're going to calculate the range. So store A, if you look, the highest number is 150 and the lowest is 24. So we know range is highest minus lowest. So this range is 126. Okay, if we come over here to store B, we have 120 minus 30. So we have 120, minus 30 is 90. So the range of the data for store B is 90. So I guess they just want us to rewrite these here. The range for store A is 126 and the range for store B is 90. So now we're going to just calculate the interquartile range. Now remember, the interquartile range is the difference between the upper quartile and the lower quartile. Okay, so the upper quartile is 72. They've already done it for us. And then 48. So they already have that for you. So the interquartile range for store A is 24. And then over here, upper quartile, lower quartile, so 100 minus 42 is 58. So the interquartile range for store A is 24, and the interquartile range for store B is 58. So store A has a greater range, right? Because they have 126, whereas store B is just 90. But store B has a greater interquartile range. I'm just going to call that IQR, even though interquartile is one word. So technically that should be a smaller q maybe. I don't know, just so we don't have to write it all out. Okay, so both are measures of variability based on the difference between two values. The range uses the difference between the two most extreme points, the highest and the lowest. The interquartile range uses the difference between the upper and lower quartiles. Okay, so let's take it to the Sharon show. And number 1 says, find the range and interquartile range of the data in the box plot. So I'd like you to pause the video and right now find the range and the interquartile range. So this one is range. Here's interquartile range. And I'd like you to pause the video and solve those two. Okay, thank you for pausing. So to find the range, we would do 19, because 19 is the highest number, minus 7, which is the lowest. So the range for the t-shirt cost in dollars is $12. Okay, for the interquartile range, we're going to find the difference between the upper and the lower. Well, look, they've already done it for you. So here's upper because it's higher on the number line, 15, and here's lower, which would be 12. So we'd have 15 minus 12 is 3. So the interquartile range is $3. Okay, simple enough. It's all review except for that interquartile range. But as long as you have your upper quartile and your lower quartile, you just subtract them and you get your interquartile range. So I think the trick and the challenge for this chapter is to just keep your vocabulary straight. Okay, so I'd like you to look at number 2. The heights in inches of several tomato plants, and find the mean absolute deviation for number 2. Okay, so you might have to look back in the video or look back in your book and remember how to find the mean absolute deviation. So go ahead and pause the video and please do number 2. Okay, so the MAD, or the mean absolute deviation, and you need to probably make sure you're showing some work, probably on loose leaf, there's not a lot of room here. The mean absolute deviation for this problem is 1 inch. Okay, go ahead and pause the video. I'd like you to find the mean absolute deviation of number 3. Thank you for pausing. So the mean absolute value for number 3, mean absolute deviation, sorry, is 10 seconds. Okay, so if you're having trouble on 2 and 3, or you had trouble, you didn't get the right answer, it might be because you didn't show your work neatly, label your work, work it all out, use your calculator, or you don't understand it, in which case you should probably go back to 13.3, where Mr. Damiani did mean absolute deviation with you. Okay, great. Let's go to the on your own. Use the box plot for 4 and 5. So number 4 said, what is the range of the data? Well, we're going to take the highest value, which looks like it's 56, and the lowest value, which is 32, and subtract. Okay, so this would be $24 because it's price of pottery sold in dollars. So we've put a dollar sign. Number 5, what is the interquartile range of the data? Well, remember, we're going to take the upper quartile, which looks like it's 52, and subtract the lower quartile, which is 36. So for this one, we'd have 52 minus 36, which gives us 16. So the range of that data is $24 and the interquartile range is $16. Okay, so right now I'd like you to stop the video, rewatch it if you need to, and please do your WSQ. So you've already done your W, check that off. Now you're going to summarize the lesson and ask one question, open-ended hopefully. If there was something you did not understand in the video, then write a question having to do with that. If you understood everything in the video, then you need to go to your Bloom's Taxonomy flip chart. Tons of questions are listed there. Try to find a really challenging question to pose to your group for tomorrow's lesson. Okay, everybody, hope you have a wonderful afternoon and evening, and we'll see you in the hallways.